Hello and very good evening to all of you. Welcome to Resultant JE YouTube channel. I'm Vikas Vadoria and I welcome you all to the first lecture for RRB JE 2024. This is a lecture on the subject of thermodynamics. Well, I know that most of you must be thinking, if we talk about SSC JE, then thermodynamics and applied thermodynamics is having maximum weightage. But if we talk about railway, and if you see the previous year weightage, then complete thermodynamics and applied thermodynamics has got a total weightage of 12 marks. Well, out of 100, 12 marks are not less. Well, apart from thermodynamics and applied thermodynamics, I will also be taking the subject of fluid mechanics. So, first of all, I welcome you all on this YouTube channel of Resultant JE. This is the new platform where I will be teaching you my subjects of thermodynamics, applied thermodynamics. This channel is basically started only for you students so that we can teach you for the upcoming examination of JE. And as you know that RRB JE is the exam which is going to happen after around 5 years. So those who are preparing for this examination, I guess these sessions will definitely help you for your CBT2 of RRB JE and SSC JE CBT2 as well. Okay, so I know that most of you, those who have given SSC JE examination, you must be preparing for CBT2. So SSC JE CBT2 this session will be helpful for SSC JE CBT2 as well as RRB JE CBT2. Hi Vikas, good evening, welcome to the session. I request all of you, those who have joined the session recently, just joined the session, please like and share the session as well. And also tell me, is my audio and video is fine? Yeah, please confirm me about the audio and video as well. 3 marks into Neva. Okay, no problem, Kumar Prashant, that's not a problem. Barg stipendary trainee was although having so many vacancies. And if you have not cleared the interview because of 3 marks, that doesn't mean that you are not qualified enough for not getting selected. It's just that was not your best day, right? So getting not selected because of interview, that is not something in your hand. Okay, prepare for other exams. Your knowledge is not going to waste. Okay, आपकी knowledge waste नहीं हो रही. Okay, so please prepare for other examination. CBT1 में sir 74 थे. Okay, no problem, Prashant. You are talking about SSC JE CBT1. That means your CBT1 is not clear, SSC JE. What about RRB JE? Are you going to prepare for RRB JE? Right? I hope you will be preparing for RRB JE. So those who are going to write your exam for RRB JE, get ready. This is the best time for you. ओके एनसीएल में 90 था, 2 मार्क्स से नहीं हो हुआ. ओहो, 2 मार्क्स, 3 मार्क्स. दैट मीन्स यू आर जस्ट इट्स जस्ट दैट लक इज नॉट इन योर फेवर, कुमार प्रशांत. थोड़ी सी मेहनत और करना पड़ेगा एंड यू कैन डेफिनेटली रीच योर टारगेट्स. ओके, एंड डोंट गेट डीमोटिवेटेड बिकॉज ऑफ नॉट गेटिंग सेलेक्टेड इन फ्यू एग्जामिनेशन. So let's begin, दोस्तों. Let's start the session and let's not waste our time because it's very important for you guys. And I'm going to teach you after a very long time on this new platform Resultant. So please do not forget to subscribe the YouTube channel, okay, and press the bell icon. My dear students, also do not forget to like and share the session and subscribe the YouTube channel. First of all, those who are joining me for the very first time, let me tell you something about myself. My name is Vikas Vadoria and I am a faculty who has been teaching from around 7+ years. I have done my MTech in thermal engineering from Thapar University and mentored more than 1 lakh students for different competitive exams like GATE, Engineering Services, SSC JE and other JE exams. Okay, and most of you have already seen my sessions. You must have gone through my lectures. The subjects that I teach are fluid mechanics and thermodynamics, applied thermodynamics, and these are the subjects that I will be taking in this on this particular channel. Okay, so you will be getting complete information, complete knowledge, complete clarity of concept, complete practice on these subjects, I guarantee you that these subjects will be taken care of by me in the best possible manner. Fluid mechanics and thermodynamics, applied thermodynamics. So as you know that it's already 7 minutes, so let's start the first question. Which of the following thermodynamic law gives the concept of enthalpy? Come on everyone, I know that most of you are, I have taught you so well that you will be able to answer these questions very easily. Yes, tell me my dear students, what will be the answer to the first question? Which of the following thermodynamic law gives the concept of enthalpy? That is first law of thermodynamics. Why first law of thermodynamics? Because first law of thermodynamics is the only law which talks about the concept of energy. It talks about internal energy. Okay, it defines energy, it defines internal energy, it defines enthalpy. Yes, so these all being defined by first law of thermodynamics. And why we should not see second law? Second law क्या बताता है? Second law tells about entropy. Third law tells about absolute temperature. Yes, my friend. As you know, my teaching method is I revise everything. Fourth law, there is nothing like fourth law. Okay, this is not fourth law, zeroth law of thermodynamics, which tells about temperature. Okay. Yes, we you guys can follow this session for the practice, and in the coming future I will be also giving you some theory classes. Okay, so these classes will definitely be helpful for you, I promise you that. What is the relationship between Kelvin Planck and Clausius statement? इनके बीच में क्या relation? What is the relation? Tell me. Violation of one does not violate the other. Violation of Kelvin Planck statement. Both are second law of thermodynamics statement. Both belongs to second law of thermodynamics. Okay. So what is important about these two statements? They are called as virtually two parallel statement of second law of thermodynamics. They are virtually two parallel statement. Although these two statement looks different. ऐसा लगेगा दोनों statement different. If you see Kelvin Planck statement talks about the concept of heat engine, right? It tells that it is impossible for any device to convert the entire heat into work. It is not possible to convert entire heat into work with a single reservoir. That is not possible. Single reservoir, with the help of single reservoir, you cannot entirely transfer entire heat into work. That is impossible according to Kelvin Planck. And Clausius tells us that it is impossible to transfer the heat from low to high temperature. Low से high temperature, it is not possible to transfer the heat without work input. That is Clausius. Although these are two different statements, but if you violate one statement, other statement automatically get violated. That is why they are called parallel statement of second law. Okay. Next question. 2 kg of a liquid system having specific heat of 2.5 is stirred in a well insulated chamber. So we have a chamber which is well insulated. Okay. Please focus on this thing. Insulated chamber means there is no possibility of heat transfer from this chamber, right? There is no possibility of heat transfer from this chamber. 2 kg of the liquid, it contains 2 kg of liquid. Okay, 2 kg of liquid having specific heat of 2.5 is stirred. Stirred means we are just trying to move the fluid. Okay, causing the temperature to rise by 10. Temperature to rise means increase in temperature is equal to 10 degrees Celsius. Okay, ऐसे दोनों पैरेलल स्टेटमेंट बिकॉज दोनों डायरेक्शन के बारे में बात बोलते हैं. No, the meaning of parallel statement is not about direction. The meaning of parallel statement is, Prashant, this might come in the interview also and your answer is not correct. Okay, parallel statement, the meaning होता है, the meaning of parallel statement is that if you violate one statement. जुड़वा movie देखी, have you seen जुड़वा movie? So if you hit one person, the other person also feel. So if you violate one statement, other statement will also get violated. If you violate Kelvin Planck statement, violate means if any device will not follow Kelvin Planck, then Clausius will be violated. If any device will violate Clausius, Kelvin get violated. So that is the meaning of parallel statement. That is, although these two are two different statements, but if you violate one statement, other will get violated. That is the meaning of parallel statement. Okay. All right, Prashant, I don't want next time in any interview this question comes and you give this wrong answer. Okay, so 2 kg of the liquid, specific heat is given, insulated chamber, temperature rise is given. Now firstly we need to focus what is being asked here, heat transfer and work done. Okay, now heat transfer is 0, So I think this, most of you will say that, yeah, definitely A and B cannot be the right answer because heat transfer will be 0. It is an insulated chamber, my friends, right? Now, according to first law of thermodynamics, Q minus W is equal to delta U. If this is 0, then definitely work will be equal to minus of delta U, right? Delta U will be, change in internal energy will be equal to M CV delta T. M is equal to 2, CV is equal to 2.5, delta T is 10. The answer will be 50. But this is change in internal energy. Work will be minus of change in internal energy, that is minus 50. Minus 50 means work is done on the system. Work done on the system is 50. Please take care of sign convention also. Sign conventions are also important, okay? Because it is work is negative means work done on the system. Hello Govind, good evening, welcome to the session. Yes, I have forgot one thing, that I have not shared this video, and please I request everyone to share the video as well, and you can share in your telegrams. All right, do not forget to share the video. And this is my first video on this YouTube channel, and I've been teaching you, I will be teaching you after a very long time. So those students who were asking me, sir aap kab se padhayenge, when are you going to teach, at least they should get a message that I have started teaching, and they can come to my classes and they can go through these classes. Okay, next question. A rigid tank contains 0.05 meter cube of saturated water vapor at 370 kilopascal pressure. What will be the mass of vapor inside the tank? So how are you going to solve this question? On the system negative में, तो वही तो कह रहा हूं मैं, that is what I am telling you, Kuldeep my dear, work is coming out minus 50. That means minus 50 means work done on the system. अब daily class होगी, yes, the class will happen daily at 8 PM. Few days I will be taking the classes, few days Suraj sir will be taking the classes, on few days Dheeraj Sardana sir will be taking subject of production, and he has a vast experience of more than 10 plus year teaching production, so he will be teaching you production. Okay, so all the faculties, most of you are already familiar, and they are the best faculty. So if you see at pressure of 370 kilopascal, mass volume is given as 0.05 meter cube. So firstly we should write the given data. What data is given? What will the mass of the vapor inside the tank? And at 370 kilopascal, a specific volume is given. A specific volume is 0.5 meter cube per kg. It's a very simple question because you know that a specific volume is equal to volume per unit mass. So mass will be equal to volume by a specific volume. Volume is 0.05, a specific volume is 0.5. If you solve it, you will get the answer. Right? Simple question. Are you getting this? I hope. So I request a YouTube production ka theory karwa di. Yes, Kumar Prashant, Dheeraj Sardana sir will be taking the subject of production. And like I told you, he is having a very vast experience and he will be taking the entire production and material science subject. Okay. So if you solve it, you will get the answer. Yes, tell me what value you are getting. Yeah, some of you are also doing mistake. I can see that. The answer will be option D. Next question. What will be the heat input to a Carnot engine that operates between a source temperature of 900 Kelvin and sink temperature of 300 Kelvin, and it produces 100 kilojoule of work? 100 kilojoule of work. Hello Pushpin, good evening, welcome to a session. See, my dear students, heat input is being asked. Source temperature, that is high temperature, is given. High temperature is 900 Kelvin. Okay. Low temperature is 300 Kelvin. Okay. Work is given as 100 kilojoule. If it is a Carnot engine, my friend, do we know a relation? Yes. For Carnot engine, we know a relation that I have taught you very well. I hope you have not forgotten that. Carnot engine, heat supplied by heat rejected is equal to temperature at which heat is supplied divided by temperature at which heat is rejected. And my dear students, in this question, you cannot apply this technique because you don't know the heat supplied and heat rejected is not known to you. So firstly you have to find the efficiency, that is 1 minus lower temperature by higher temperature, which is equal to work done divided by heat supplied. You can use this relation. If you use this relation, you will get the answer very easily. It will be 1 minus 300 by 900 is equal to work done, which is 100 divided by heat supplied. Clear? This relation, when you use this relation is used when you know the heat supply, heat rejected, and one of the temperature is given, other temperature you have to find. Or TH and TL is given, heat supplied is given, heat rejected have to be found. So this formula will be used in that situation. Okay. If you solve it, you will get the answer. What is the answer you are getting? Tell me. Yeah, option A, 150. Are you all getting 150? Okay. Next question is, a thermal energy reservoir is a large body of. Thermal energy reservoir is a large body of source and sink. They are called as thermal energy reservoir. Source example is sun, earth. These are the sources of the heat. No matter how much heat you can take from them, their temperature will remain same. They will be maintained at high temperature, constant high temperature. Sink is that which no matter how much heat you give to the sink, its temperature is going to remain constant. Okay, it will maintain at constant low temperature. Clear? Are you getting this? So if they are having constant low temperature and high temperature, Q is equal to MC delta T. What is heat capacity? First of all, this is the heat capacity. Heat capacity. So these energy reservoir, thermal energy reservoir will be having heat capacity is equal to what? Sorry. Because delta T is change in temperature will be 0. Here also change in temperature will be 0, right? So temperature change is 0, so this will be infinite. So they will be having infinite heat capacity. Very good. So I always tell you, my dear students, चीजों को रटना नहीं है. You don't have to mug up the things. Okay? You don't have to याद करना नहीं है. आपको इसको समझना है. All right? Next question. One reversible heat engine operates between 1600 and T2 degree Kelvin, and another between heat engine. वैसे first of all degree we don't use Kelvin. We don't use degree with Kelvin. Okay. If both engine have same input and output, same heat input and output means work output. If the work output and heat input is same, that means efficiency is equal to work output divided by heat input. Okay. So if both engine are having same heat input and work output, that means they will be having same efficiency. And if they are having same efficiency, then their intermediate temperature will be equal to geometric mean. This is the technique that you have to remember. This is a trick. I told you so many times that if they are having same efficiency, you have to apply this geometric mean technique. Okay. So if you apply geometric mean 1600 into 400, it will be 800 Kelvin. But what if the work output have been equal? If the work output would have been equal, then in that situation, the intermediate temperature will be arithmetic mean, that is T1 plus T3 by 2. In that situation, the answer will come out to be 1000 Kelvin. Yes, my friend. Okay. Are you getting this, everyone? Clear to everyone? Next question. A heat engine is supplied with 250 kilojoule per second of heat at a constant fixed temperature of 227. The heat is rejected at 27 degrees Celsius. If the cycle is a reversible one, amount of heat rejected is. Remember, I told you this concept. I have just told you this concept that if it is a heat engine and that is a reversible engine that is working on reversible cycle, then you can apply this formula. Heat supplied by heat rejected is equal to higher temperature by lower temperature. You can apply this formula, you will get the answer. Just put the values. It is supplied with 250 kilojoule per second heat. Heat rejected, you have to find. High temperature is C. Single temperature should be kept in Kelvin. So this should be kept in Kelvin. That will be 500 Kelvin. This will be 300 Kelvin. Solve it. Okay. What you will get? Heat rejected will be equal to 250 into 3 divided by 5. That will be 150 kilojoule per second. Okay. Option A will be the right answer. Clear to everyone? Next question. A machine that continuously supplies mechanical work without some other form of energy disappearing simultaneously is known as? Can you tell me the name of this machine? It is continuously supplying mechanical work. It is continuously supplying mechanical work. Work is being supplied, but no energy is coming out. Work is being supplied, but nothing is coming out from this. That is definitely a device which is called as PMM1. Why PMM1? Because it is destruction, destroying the energy, destroying the energy. It is destroying the energy, and energy can neither be created nor be destroyed. It can only be transferred from one form to another. So this is a PMM1 device. Okay, clear to everyone? Is it clear to everyone? Tell me. Next, a heat pump is used to maintain a hall at 300 Kelvin. A heat pump is used to maintain a hall at 300 Kelvin when the atmospheric temperature is 270 Kelvin. Okay, the heat load of the hall is 30 kilowatt. What will be the power required to run the heat pump? Assume the COP of the heat pump is 30% of the COP of Carnot heat pump, working between same temperature limits. This looks like a big question, but let me tell you, my friend, have you seen CBT2? Conditions of CBT2? In RRB JE CBT2 also, calculator is allowed. Calculator. So calculator is allowed. When you see this thing, calculator is allowed, then most of your heartbeat goes very fast. That means question level will be very tough. They will be like gate questions. No, they will not be like gate questions. We have seen the same thing for SSC JE CBT2 as well. Question level will not become very high, right? Only thing is that the question will be of engineering services level. There will be some calculation which cannot be done without calculator, but that will not be that kind of calculation that is required for gate questions. Okay, so calculator is allowed for CBT2 of RRB JE as well as SSC JE. That doesn't mean the question level will become like gate question. That will not be the scenario. Okay, first of all, let me assure you that. Okay, clear? Now see this question, heat pump. First of all, temperature is given. What we know, temperature is given for this. So Carnot COP of the Carnot heat pump will be, Carnot heat pump COP will be high temperature divided by high temperature minus low temperature. You can just apply this. It will be 300 divided by 300 minus 270, that is 30, that we will get 10 COP. Yes. Now, the COP of this heat pump is 30% of the COP of Carnot heat pump. Carnot heat pump ki COP ka kitna hai? It is 30%. Now, if you apply the 30% of the actual COP of the heat pump will be 0.3, that is 30% into 10, right? It will come out to be 3. It will come out to be 3. Actual COP will be 3. Carnot COP is 10. Clear to everyone? Now, what is the question? It is used to maintain the heat 30 kilowatt. The heat load is 30 kilowatt. If the heat load is 30 kilowatt, then we know one more formula for COP, and that is COP is equal to, I have to hide myself for some time. COP is equal to desired effect, that is heat load divided by power input, right? Simple. Apply this formula. Okay, so power input will come out to be, heat load is equal to 30 and COP, this COP you have to put here, that is 3, that is 10 kilowatt. Clear to everyone? And I think there is some mistake here, my friends. A, B, what is this mistake? C, D. A will be the answer. Okay, clear to everyone? Is it clear to all of you? Yes, tell me. And those who are coming to the session, please do not forget to like and share as well. Okay, tomorrow will be fluid mechanics session. So I think one of the students was telling me, sir, for RRB JE, fluid mechanics is having more weightage. So let's cover more question from fluid mechanics. I will definitely cover question from fluid mechanics. Don't you worry about these two subjects. I will be taking the subjects of thermodynamics, applied thermodynamics and fluid mechanics. Suraj sir will be taking the subjects of mechanics and industrial. Studies will be taking some important subjects of mechanics, industrial, and I don't exactly remember all his subjects. And Dheeraj sir will be taking production. So all the subjects will be taken by best faculty who are having lot of experience in technical. Okay, so be assured for that. Which of the following is true? Reservoir that supplies energy in the form of heat is known as thermal energy sink. Supply the energy in the form of heat is no. A reservoir that absorbs the energy in the form of heat is known as thermal energy source. No. A reservoir that supplies energy in the form of heat is thermal energy source. Yes. Option C. जो energy supply करता है, the one who supplies the energy is called source. One who absorbs the energy is called sink. And thermal efficiency of the heat engine is always 100%. No, it is impossible. It is impossible. If any engine will dare to do that, it will be called PMM2. PM2 is a hypothetical device which violates second law of thermodynamics because it tells us that you can achieve 100% efficiency. That is not possible, and so that is why PM2 is a hypothetical device which violates second law of thermodynamics. Next question is, which of the following is true? When the temperature of the vapor is less than the saturation temperature corresponding to the given pressure, the vapor is said to be in superheated state. When temperature of the liquid is less than the saturation temperature. This is a very conceptual question. Conceptual question. And when we talk about concept, you know that concepts are something which cannot be mugged up. आप इसको याद नहीं कर सकते, आपको उसे समझना पड़ेगा. You have to understand the concept, right? So, let me tell you one thing about properties of pure substance. You remember properties of pure substance topic? When you do the phase change, phase transformation, superheated, first of all, let us understand this phase transformation diagram. This is a superheated vapor region. Superheated vapor region. Okay? Superheated vapor region. This is compressed liquid region. Compressed liquid region. This is a wet vapor region. Wet vapor or saturated liquid per plus mixture. That is mixture region. Liquid plus vapor mixture region. Okay. Now try to understand it. When the temperature of the vapor is less than the saturation temperature, here we have saturation temperature at which phase transformation takes place. When temperature of the vapor is less than saturation temperature, it is called superheated. No. When temperature is less than saturation temperature, it is called as compressed liquid. It is called as compressed liquid. How many of you know that? आपको आंसर नहीं देना है, मुझे बताओ. First option is incorrect, right? It is called compressed liquid. When temperature of the liquid is less than saturation temperature corresponding to the given pressure, the liquid is said to be compressed. Yes, option B is the right answer. Okay, which of the following is true? Option B is correct. When the temperature is less than saturation temperature corresponding to given pressure, it is called compressed liquid. Yes. When the temperature of a liquid is less than the saturation temperature, this is incorrect. No, this is incorrect. When temperature is greater than saturation temperature, it is called superheated vapor. Okay, at a given pressure, when the temperature is greater than saturation temperature, it is called superheated vapor, and when the temperature is less than saturation temperature, it is called compressed liquid. Good evening, Aniket. Good evening, and good evening to everyone, all the students whom I was not able to wish good evening, whom I have missed somehow. Good evening to everyone, and I'm meeting you all after a very long time. And last time I taught you for SSC JE 2024 paper 1. I hope all of you have given your best in that paper, and very soon the results are going to come. An ideal gas or gobi is a volume of 0.5 meter cube at a pressure of 8 bar, temperature of 400 Kelvin. Gas undergoes a thermodynamic constant volume process until the pressure rises to 10 bar. What is the temperature of the gas? So first of all, you need to understand this thing. Constant volume, this is something which is of my interest. If the volume is constant, then which is a law? Remember, it is called Gay-Lussac law. Volume is constant, it will be Gay-Lussac law. It says that then pressure is directly proportional to temperature. That is, the final pressure by initial pressure is equal to final temperature by initial temperature. Just apply this thing. The final pressure is 10 bar, initial pressure is 8 bar, right? Initial temperature is also given, that is 10 by 8 is equal to final T2 is you have to find, and T1 is given as 400. Just apply this. You will get T2 is equal to 10 into 400 divided by 8, which is 500 Kelvin. Clear to everyone? Right? Class Hindi mein nahi hogi. No, the classes will be in English, but try to understand this thing, that if you are having any problem in understanding anything, you can let me know. Okay? Clear? The classes will be in English, but if you feel anything which you are not able to understand, then you can tell me. I can repeat for you. Okay? 2 kg in Hindi. 2 kg of liquid having a specific heat of 3 is stirred in a well-insulated chamber, causing the temperature. Similar kind of question we have done in the start, right? In the beginning. Remember? What will be the amount of work done on the liquid or system? So, you know that it is an insulated chamber. Insulated chamber means there will be no heat transfer, first of all. And first law of thermodynamics says that heat transfer minus work is equal to change in internal energy. If this is 0, my friend, then work is equal to change in internal energy. Work is equal to minus of change in internal energy. Minus of change in internal energy is 2 into 3 into 15. That is minus 90. You don't have to consider the sign. Answer will be 90. Because it is already asking the work done on the system, which will be obviously negative, minus 90. Which of the following is true? The question regarding dryness fraction. You know that dryness fraction is equal to mass of the dry vapor divided by mass of the dry vapor. ये formula आपने पढ़ा है, you have read this formula, divided by mass of the liquid in suspension. Liquid in suspension. Clear? Is it clear to everyone? Now this dryness fraction, my dear friend, is only applicable for which region? For the wet region. In the wet region, this dryness fraction is greater than 0 and less than 1. It is equal to 0 for the subcooled, this line, saturated liquid line, and it is equal to 1 for saturated vapor line. Clear? The quality or dryness fraction of the liquid vapor mixture is greater than 1. Wrong. It is between 0 to 1 in the wet region. Okay? Quality of the compressed liquid ranges between 0 and 1. No, it is 0. Quality of dry saturated vapor is 1. Yes, dry saturated vapor quality means dryness fraction is equal to 1. Clear? Clear to everyone? Next. A researcher claims that he has built a heat engine. A researcher has claimed that he built a heat engine that operates between 27 and 10 degrees Celsius. This engine produces work of 10 kilowatt and heat rejected is 165. This engine is impossible. This engine is probable, possible, reversible. First of all, you know that how you can tell that engine is possible or not. The high temperature is given 27 degrees Celsius, which is 300 Kelvin. Low temperature is given as 10 degrees Celsius, which is 283 Kelvin. Work output is equal to 10 kilowatt and the heat rejected is equal to 165 kilowatt. So first of all, we need to find the efficiency, and for efficiency, you know that we have to find two efficiency. See, this question can be done by two ways. Okay, we know that heat supplied minus heat rejected is equal to work output. Heat supplied will be equal to work output, that is 10 plus heat rejected plus 165. Just a second, 165, which will be 175, okay, kilowatt. Now, this question can be done by two ways. One is you can find the actual efficiency. Actual efficiency will be equal to work output divided by heat supplied, which is 10 by 175. 10 by 175, this you can do, right? You can find the actual efficiency, you can find the Carnot efficiency, which will be equal to 1 minus lower temperature by high temperature. This is one way. And you can compare those two efficiency and you can tell if it is impossible when actual efficiency is greater than Carnot. Okay? If actual efficiency is equal to Carnot, then it is reversible. And possible is if actual efficiency is less than equal to Carnot, then it is possible. Now, you can find the both efficiency and you can let me know what is the answer you are getting. Tell me. What is the answer you are getting? You are getting this efficiency will be 5.714 and this efficiency will be this you are getting 5.67 something, 5.67. Anyways, actual efficiency is coming out greater, right? It is getting slightly greater, so it will be impossible. If this you are getting 5.67, approximation is not possible here because 5.67 is not exactly equal to 5.714. That will be the case of impossible. Clear? For irreversible process, which relation is correct? Irreversible process, which relation is correct? Loss of exergy is indirectly proportional to rate of entropy loss of exergy is directly, see, irreversible process, you know that, have you studied the Gauss-Stodler theorem? Gauss-Stodler theorem. Gauss-Stodler theorem of irreversibility for irreversible process tells us that irreversibility is directly proportional to entropy generation. Irreversibility is directly proportional to entropy generation. What is irreversibility? Irreversibility is nothing but loss of available energy. And available energy is what? Exergy. So can we say that loss of exergy is directly proportional to entropy generation? It is directly proportional to rate of entropy generation. Option B is the right answer. Clear to everyone? Clear to everyone? For irreversible process, the irreversibility or loss of available energy or exergy, exergy is available energy, is directly proportional to rate of entropy generation. Next question. So this is a question. An ideal gas is heated from temperature T1 and T2 by keeping its volume constant. The gas is expanded back. This is a homework question for you today. Okay. We have solved this question many times. I think we can solve it today also, but I want you to solve it. Let me see how many of you are able to solve it. Ideal gas is heated from temperature T1, T2 by keeping its volume constant. The gas is expanded back to its initial temperature according to this law, which is polytropic law. If the entropy change in two processes are equal, which two process? One is D option. Which D option? This option. Loss of exergy is equal to rate of entropy. No, it is not equal. Directly proportional. You cannot say it is equal. It is directly proportional to entropy generation. That is the Gauss-Stodler theorem for irreversible process. Okay. So try to solve it. A small hint for you guys is for constant volume process where temperature changes from T1 T2, the entropy change will be equal to mCv log of T2 by T1. For the gas expanded back to initial temperature, entropy change in the two processes are equal. Second process is polytropic. Polytropic process, entropy change you have to find. It will be m specific heat of the polytropic process into log of T2 by T1. It is very simple. And specific heat of polytropic process, you know that it is minus Cv of gamma minus n over n minus 1, something like this. So just equate these two. You just equate these two entropy relation and you will get the answer. Try to solve it, you will get the answer. Okay. I think I have told you enough. The answer will come out to be, if you solve this question, if you compare these two will be equated. Okay. This will get cancelled out, this will get cancelled out, this will get cancelled out. If you solve this, you will get this answer. Okay, so I thought I will give you homework, but I think I have told you majority of things, so you will get this answer. Okay, next question. For a quasi-static thermodynamic process 1 to 2, which of the following is not correct? Which of the following is not correct? Quasi-static thermodynamic process. See, if you see the first question, the first option is integral of work is equal to change in this. They have applied just limit for the work. This is not possible. This is not possible. Why it is not possible? Can you tell me? Because work is inexact differential. It is inexact differential, and for inexact differential, this integration is not possible. This can only be done for an exact differential, and they are exact differential. They are exact differential. They all are properties. They all properties. Properties are exact differential. Properties are exact differential. You can easily integrate the exact differential and you can do this. This is possible. This is not possible. This is not correct. A Carnot cycle operates between source temperature of T1 and sink temperature of T2, where T1 is more than T2. If the source temperature increases slightly and sink temperature is decreased by the same amount, then what will be the effect of these changes on engine efficiency? So I hope you guys have noticed there are two cases. One case, case number one is, we have a Carnot engine which is operating normally. If you see the Carnot engine having efficiency of 1 minus T2 by T1. Okay, this will be the normal efficiency of the engine. If you know that T1 is more than T2, that is T1 is the source temperature, T2 is the sink temperature, right? Okay, now efficiency of the engine will be, in the first case, source temperature is increased slightly and sink temperature is decreased by same amount. So in the first case, source temperature, sink temperature is constant and source temperature is increased. This is increased by T temperature. In the second case, case number 2, sink temperature is decreased by the same amount. It is decreased by the same amount and source temperature is constant. So you know that which will be having more efficiency. Decreasing the lower temperature will increase more efficiency. You know that decreasing the lower temperature will have more effect on efficiency. So this will be the more effect. Efficiency will, what will happen to the efficiency? Efficiency will increase, that because firstly you are doing source temperature increase slightly and sink temperature decrease by the same amount. Okay, so efficiency will increase. Yes. Next है, which of the following statement about steam is incorrect? Which of the following statement about the steam is, guys, just wait for 3 to 4 minutes more and I will be winding up the session. I have taken so many questions from thermodynamics. Okay, just be with me for next few minutes. Which of the following is incorrect? Dryness fraction is a term concerned with wet steam. Wet steam, yes, correct. Wet steam has a dryness fraction of more than 1. This is not correct. More than 1 dryness fraction is not possible, so this is incorrect. Clear? Latent heat is the heat required to convert water into steam at a given time. Yes, when you have to convert water into steam, which heat you give? Which is the heat which is given when you have to change water into steam? That is the latent heat. at constant temperature, at same pressure and same saturation temperature, you give latent heat. So this is correct. This is superheated steam follow law perfect gas. That is correct. This is incorrect. In a heat pump, process of the cycle are carried out in such a manner that sequence of process in the PV diagram. In a heat pump, the process of cycle are carried out in such a manner the sequence of process in the PV diagram. Okay. If you see PV diagram of a heat engine PV diagram, let's say it is following the Carnot one. Now, so if you say, let's say we are talking about a Carnot heat pump. So Carnot engine will be having this kind of process 1, 2, 3, 4 on pressure volume diagram, right? And what will happen to the Carnot heat pump? Carnot heat pump will be having exactly same thing but in anti-clockwise direction. So this, just a second, huh? It will be having same thing in the anti-clockwise. Okay, it will be anti-clockwise cycle. This is a clockwise. Okay, so what will be the answer? It is in anti-clockwise. Clear? Next, which of the following statement is true about the entropy? All the adiabatic processes are isentropic process. All adiabatic processes are isentropic. Entropy of an isolated system may increase or decrease according to the value of internal irreversibility. Entropy of universe always increase for all practical process. Entropy of a system is an intrinsic property. Which of the following is true? Entropy is intrinsic? No, it is a extensive property. This is incorrect. So my dear students, which will be the right answer according to you? This option C. Entropy of universe is isolated system. Isolated system, and you know that practical. What is the meaning of practical? Practical means real, something which is real. And what is real? In reality, you will find irreversible process. In reality, you will find irreversible process, right? And for irreversible process, entropy change of universe is equal to entropy generation for practical process. Practical means irreversible, right? And entropy generation is always positive, right? So that is why answer. And why you think option A is not correct? Tell me. Because only reversible adiabatic are, not all adiabatic processes are isentropic. Reversible adiabatic process. All reversible adiabatic processes are isentropic. Are you getting this? So that is why option A is not correct. If two liquids at different temperature are mixed, two liquids at different temperature are mixed. Let's say we are having two containers. Okay, one container is containing liquid number A, liquid A. Okay, second container is containing liquid B. All right. Now, if both the liquids are mixed, temperature, and this is having temperature T1, this is having temperature T2, and both are having different temperature. Let's say T1 is more than T2. What will happen? Then final temperature of the mixture of liquid can be obtained by using. How you are going to obtain that? By using first law of thermodynamics. By using first law of obtained. When you will obtain the final temperature, that will be by the principle of calorimetry. That is, let's say both come under some final temperature, equilibrium temperature, that is the final temperature. So the final temperature of this liquid A will be less than the initial temperature because it will lose the heat. So what will be the condition? Heat lost by hot liquid will be equal to heat gained by cold liquid. This is what? This is first law of thermodynamics. Heat gained by cold liquid. So the final temperature, my dear, The final temperature is specified by, right, specified by 0th law, but calculated by, obtained by. So don't do this mistake. Next time what you will do this, right? Exam में गलती किया तो क्या करोगे? After you will come out of the exam, you will do this. क्या कर दिया? What I have done? Okay. So please see this. Obtained by, calculated by will be first law, specified by 0th law. Clear? Next question. The work extracted from the system is less than the heat provided to the system. Which of the following is true for the energy of the system? A very basic concept of the thermodynamics first law. We all know that first law of thermodynamics tells us that heat supplied to the system minus work done by system is equal to change in internal energy. The work extracted from the system is less than the heat. If work is less than the heat, definitely internal energy is going to increase. It will lead to increase in the internal energy. In most of the cases, you will find this condition, but there is also a case which leads to decrease in internal energy in the polytropic process. If you see the polytropic process, you will find that in the polytropic process, the heat supply, hi Royal Anu, good evening, welcome to a session. Yes, you are a bit late just because the session started at 8 p.m. and at 9 p.m. the session will be completed, but no problem. You can also see the recorded session after the session goes offline. So heat supply is less than the work, and in that case internal energy is negative for the polytropic process. So you have to remember this case also. Okay. Which of the following statement is correct when saturation pressure of the water vapor increases? Saturation pressure of the water vapor increases. What is the meaning of saturation pressure? So when you are in a process of changing the phase of a liquid, slowly changing into vapor, then what you will find? Initially when you heat a liquid, its temperature is going to rise. Then at a constant saturation temperature, phase change will take place, and then I have joined Resultant on Sunday, I guess. Sunday was a launch session. Gulam, good evening, welcome to the session. Okay, now at a given pressure, this is let's say constant pressure, it is also called saturation pressure. Now as the pressure is going to rise, you will notice, so this is saturation temperature, at which phase change, let's say pressure is increasing, this is constant pressure, this is also the saturation pressure. So as the pressure will be increasing, saturation temperature will also be increasing, but the latent heat is going to reduced. Okay, so as pressure increases, the latent heat will reduce, slowly latent heat is going to reduce, and at the critical point, at this particular bindu, which is critical point, the latent heat will become zero. This point, latent heat will become zero. That is called critical point. Latent heat will become zero. But as pressure will increase, the saturation temperature will. When saturation pressure of the water vapor increases, saturation temperature increases, and enthalpy of evaporation, which is also called latent heat of evaporation, will decrease. So option B will be the right answer. Next question. How a condensation of a mixture consisting of saturated liquid and saturated vapor is represented on enthalpy entropy diagram? First of all, what is the enthalpy entropy diagram? It is also called Mollier diagram. Remember this thing because this is also asked in many exams. What is Mollier diagram? It is a plot between enthalpy and entropy. It is a diagram of enthalpy and entropy where enthalpy is kept on the y-axis and entropy is kept on the x-axis. Okay, so this plot is called as, this kind of diagram is called as Mollier diagram, where you will find these kinds of lines. These are called as dryness fractions line. Okay, and you will find these kind of inclined lines as well. If you go in the upward direction in this inclined line, you will find the evaporation. If you go in the downward direction, it is called condensation. So this here condensation is option D, inclined line. Okay, so the inclined line with constant slope. What is the meaning of constant slope? So these kind of lines, these are the inclined lines. And if you go from this saturated vapor, this is saturated vapor. So saturated vapor to saturated liquid. So this is called condensation. Clear? And why it is called constant slope? Because slope of the molar diagram is dH by ds at constant pressure is equal to absolute temperature. This is also called as slope of the molar diagram. Slope of molar diagram. And why it is constant in the wet region? Why it is constant in the wet region? Because in the wet region, pressure and temperature are constant. In the wet region, pressure and temperature are constant. Pressure is constant, temperature is constant. So because temperature is constant in the wet region, slope will be constant. Okay. A heat engine receives heat at a rate of 1 kilowatt from a reservoir maintained at 800 Kelvin and produces 1 kilowatt of power. Then heat engine receives heat at a rate of 1 kilowatt. Okay. All right. So this particular heat engine, which is maintained at 800 Kelvin, and it receives 1 kilowatt heat. All right, and produces same 1 kilowatt of power. So it is very obvious that this engine is fully utilizing. This is a perfect engine. That is the example that there are 24 hours of your time and you are completely utilizing your 24 hours for studying. Is it possible? Or let's say you sit for 6 hours of study, and for that complete 6 hours you are only studying. Your mind is not going somewhere else. Your mind is not getting into the phone, right? Or it is not getting distracted. It happens. If you sit for 6 hours of study, you will be only studying for 5 hours or 4 hours, right? That is true. So it is not possible that this is the input and you are completely converted into output. This is PMM2. This is PM2 because it violates second law. It will violate second law. But does it violate first law also? Now, according to first law of thermodynamics, net heat transfer should be equal to net work transfer. According to first law of thermodynamics, for a cycle, net heat transfer should be equal to net work transfer. Is it happening here? Yes. This is violating. It violates second law. This device violates second law, but does it violate first law? No. Because according to first law, 1 kilowatt is equal to 1 kilowatt. The total heat transfer is equal to total work transfer. So it satisfies the first law of thermodynamics, but it violates the second law of thermodynamics. Is it clear to everyone? Is it clear? Hope you enjoyed today's session, and this is the last question for today's session. Entropy value always increases with temperature in any system. However, the change in entropy is zero during it is saying, this question is saying that entropy always increases with temperature. Yeah, that is true. If temperature will increase, entropy increase. However, it is zero in which case? Entropy becomes zero for reversible adiabatic process. That is a very simple question. For reversible adiabatic process, see, if the process is reversible, then entropy generation will be zero. If the process is adiabatic, then heat transfer will be zero. And you know that total entropy of any system is equal to Q by T plus entropy generation. For this particular case, both are becoming zero, so entropy change will become zero. Clear? So that's all, my dear, for the day, and rest of the question will take in some other classes. Okay, don't worry, because the time I have to teach you for 1 hour daily, and this was all for today, and rest of the question will take in some other session. Don't worry. Okay, we'll keep this session questions for the next few sessions. But tomorrow, my friends, I will be teaching the subject of fluid mechanics. Do not forget to subscribe the YouTube channel, like the session and share the session. And tomorrow, let me tell you, my friends, tomorrow I will be teaching you questions on fluid mechanics. Tomorrow, fluid mechanics questions will be taking it. Clear to everyone? All right. So see you tomorrow with the questions on fluid mechanics subject. And that's all for today. I hope you have enjoyed today's session. And those who have joined me for this session, do not forget to like and share the session. And subscribe the YouTube channel. If you have come on this YouTube channel for the first time and you have not subscribed it, please do subscribe the channel. Okay, thank you so much. See you tomorrow. Tomorrow, timing please, those who have joined me late today, the session timing is 8 p.m. for mechanical, and fluid mechanics class will be happening tomorrow at 8 p.m. Clear? Thank you everyone. Have a nice day. Thank you so much. See you tomorrow. Thank you.